In February 1945, deep inside the ruins of a bombed Allied convoy near Cologne, a German recovery team stumbled upon something that made even their most seasoned engineers pause in disbelief. It was a twisted mass of metal, half burned, half melted, but its central component, an engine, seemed unlike anything they had seen before. There were no fuel lines, no carburetors, no obvious connection to any liquid fuel system. The accompanying wreckage didn't match any aircraft in German intelligence files. Yet when examined closely, the engine bore serial numbers that pointed to something American, and something completely unknown. Within hours, the device was sent to the Luftwaffe's Technical Evaluation Center in Rechlin. The engineers there assumed it was some kind of prototype auxiliary engine, perhaps an emergency system. But when they disassembled it, they realized this was not powered by gasoline at all. The burnt insulation, magnetic coils, and strange rotating housing revealed something entirely new, an early form of an electric turbojet that appeared to generate thrust without conventional fuel combustion. At first, the Germans thought it was a mistake, but technical officers from Daimler-Benz and Junkers soon arrived, and the tone in the laboratory changed from disbelief to alarm. The war was going disastrously by that point, and Germany was months away from collapse. But if the Americans had truly developed an aircraft propulsion system that didn't depend on liquid fuel, it would mean they had just solved the greatest engineering limitation of the war. The Germans called it das Geistertriebwerk, the ghost engine. They didn't know what powered it, or even if it had been fully operational, but the design suggested it might have been a gas turbine electrical hybrid, something even the advanced Me-262 engineers hadn't envisioned. Reports from the evaluation team show that the housing contained elements of a turbine compressor, but connected to what seemed like an electromagnetic coil assembly. It looked like a bridge between two technologies, the mechanical and the electrical. The Americans, they concluded, might be testing ways to power aircraft electrically at high altitude using onboard generators, possibly even experimental batteries. To the German scientists who devoted years to squeezing a few more kilograms of thrust from the Jumo 004 jet engine, this was heresy. If true, it would make their entire jet program obsolete overnight. But the story didn't end in that lab. As the war drew to its chaotic close, a group of SS technical officers tried to move the captured engine and all associated notes to Bavaria. According to a report later filed by Allied intelligence, the convoy carrying it was ambushed near Nuremberg in late April 1945. The device was lost, but weeks later, an American technical team led by Major Donald Kiersey found a partially damaged crate matching its description in a storage depot. Inside was the same mysterious engine, tagged in German handwriting, Allied Experimental Propulsion, Origin Unknown. After the war, fragments of the so-called ghost engine were analyzed under Operation Lusty, the U.S. program to recover enemy technology. Engineers from General Electric and Westinghouse examined it, and the conclusion they reached shocked even them. It wasn't American. It was British. Specifically, it was a heavily modified derivative of an experimental British turbo-electric engine that had been in development at the Royal Aircraft Establishment in Farnborough since 1943. It had been part of a classified program nicknamed Project Hush. The goal? Create an aircraft engine that could generate its own electrical thrust using a hybrid turbine generator system, something that could power a new class of high-altitude reconnaissance planes without visible exhaust plumes. Only one prototype was ever fitted, to a highly modified Mosquito reconnaissance aircraft that went missing in early 1945 during a test flight over Europe. That aircraft, it turned out, was the very wreck the Germans had found. The concept was decades ahead of its time. The engine converted turbine-generated heat into electrical energy that could drive impeller blades magnetically. Essentially, it was an attempt at an electromagnetically assisted turbojet, a technology that wouldn't see real-world development again until the late 20th century. To the Germans who saw it in 1945, it might as well have been alien technology. But perhaps the most haunting part of the story lies in what happened after the war. In 1951, British aviation historian Dr. Harold Beckett located declassified fragments of correspondence between captured German engineers and Allied intelligence officers. One note, written by former Junkers propulsion expert Wilhelm Schwager, read, "Had we seen this device in 1943, we would have abandoned all belief in mechanical combustion. It was not of our time." The legacy of that mysterious engine didn't die in the ruins of 1945. In 1958, the United States Air Force began funding research into electro-hydrodynamic propulsion using some of the same concepts found in the recovered device. Decades later, NASA's early plasma propulsion tests would cite theoretical work that traced back to those same wartime experiments. Experiments sparked by a wreck the Germans never fully understood. To this day, no complete schematics of the original Project Hush engine survive. Some say the British intentionally destroyed them after the war to prevent the Soviets from gaining access. Others claim fragments of the documentation resurfaced in Cold War propulsion programs under different names. But one fact remains undisputed. In the dying months of World War II, German engineers, the same minds who built the first operational jet, stood in a laboratory and stared at an engine that shouldn't have existed. An engine that challenged every assumption they had about flight, power, and technology. An engine that seemed to whisper of an era yet to come, one that ran not on fuel, but on the future.
Months after the war ended, in the summer of 1946, a series of classified engineering tests began at Wright Field, Ohio, the same place where German jet engines, V-2 rockets, and radar systems were being studied under Operation Lusty. Among the shipments that arrived from Europe that year was a wooden crate labeled "Recovered from Bavaria, Allied Propulsion Experiment." Inside was the remains of the so-called ghost engine, corroded, partly fused, but still enough to ignite the curiosity of the men who opened it. Major Donald Keirsey, who had overseen the engine's recovery, watched as American engineers carefully brushed away soot and residue. To their shock, the rotor and housing didn't resemble any known Allied design. "This isn't ours," one of them muttered. "At least, not anything we built here." That confusion lasted until a second shipment arrived, a small stack of documents found in a bunker near Augsburg, written in English but tagged with a British Royal Air Force stamp. The documents referenced a thermo-electro-propulsion unit type XO, designed for silent altitude testing. That was the confirmation they needed. The mystery engine had indeed come from Britain's Project Hush, a wartime experiment so secret that even most RAF officers had never heard of it. Still, no one could explain how it worked. When American scientists at Wright Field ran electrical tests, they found that the motor's magnetic coils responded at extremely high frequencies far beyond what typical aircraft generators could handle in the 1940s. Someone, somewhere, had designed a power system capable of maintaining thousands of electrical pulses per second, using nothing but turbine-generated current. One of the engineers, Dr. Eugene Dokken, wrote in his report, "If our understanding is correct, This system generates thrust through charged airflow acceleration, an effect we have only begun to theorize. It's part turbine, part magnetron, and part mystery. The idea that an aircraft engine could partially function using electricity instead of combustion seemed absurd in 1946. But by 1947, with the US now entering a new technological race against the Soviets, the engine took on new significance. Under the newly formed U.S. Air Technical Intelligence Command, ATIC, fragments of the engine were moved to a classified division called Propulsion Section 5B, where researchers began experimenting with electromagnetic airflow, the same principle behind what would decades later be called electrostatic propulsion. And yet, as fascinating as the technology was, there was something unsettling about it. Several engineers noted strange residual magnetism in the engine's housing, strong enough to affect nearby instruments. Others reported brief fluctuations in local electromagnetic fields when testing the coils. Nothing supernatural, but certainly abnormal. The engine seemed to store energy, even when disconnected from any power source. In a 1948 memo, one technician described it as behaving like a device that wants to keep running, as if the air itself is its fuel. Meanwhile, across the Atlantic, in Britain, a new generation of scientists was quietly building on what Project Hush had started. The Royal Aircraft Establishment at Farnborough began a new program under the name Project Blue Aurora, this time focusing on compact turbine electrical hybrids. Their goal was no longer stealth or silence, it was endurance, an aircraft that could remain aloft for hours, even days, without the limits of conventional fuel. But the breakthroughs came too late. Jet propulsion had already dominated the skies, and nuclear research had stolen the attention of every major power. The Ghost engine was shelved, its potential left unexplored. Or so everyone thought. In 1952, a series of internal U.S. Air Force documents referenced something called Project Morningstar. Buried deep within those reports were design schematics for a hybrid propulsion test vehicle built at Muroc Air Base, now known as Edwards Air Force Base. The schematics bore striking similarities to the recovered Project Hush engine: electromagnetic coils around a turbine core, advanced alloys resistant to heat and electrical overload, and high-voltage control circuits unlike anything seen before. When questioned decades later, retired engineer Charles R. McLean, who had worked on Morningstar, said in a 1974 interview, "That British engine was the strangest thing we ever studied. It didn't make sense to us, but we couldn't ignore it either. Morningstar was our attempt to make sense of the impossible." According to declassified fragments, Morningstar's prototype engine ran successfully, briefly. It reportedly produced measurable thrust with minimal fuel input, driven primarily by plasma arc generation. But after just 3 tests, the project was discontinued. The reason remains classified. Some believe the instability of the system made it too dangerous. Others claim the data was redirected to early space propulsion experiments, including Project Helios and Nerva in the 1960s. But the thread linking them all traces back to that single wreck discovered near Cologne in 1945. There's another detail, one that historians rarely mention. In 1949, while reviewing captured German documents, an American translator found notes written by a Luftwaffe intelligence officer stationed at Rechlin. The note read, "Engine exhibits no fuel ports. Could be atmospheric or electrical. Impossible, yet operational. Suggest investigation into magnetic compression theories." It's a haunting line. Impossible, yet operational. That description would echo again decades later in the words of NASA engineer Harold Kaufman when describing the first successful ion propulsion test in 1961. Kaufman's quote, "It shouldn't work, but it does." From the ruins of World War II to the dawn of the space age, the line between science fiction and classified engineering blurred in ways no one could have predicted. The Ghost engine's remnants, once stored in a hangar at Wright Field, were transferred to the Smithsonian in the early 1970s, though only a small portion was ever displayed publicly. According to internal inventory logs, several components remain in storage, location undisclosed. The British side of the story is even murkier. Project Hush was officially declassified in 1984, but the surviving paperwork lists no surviving prototypes, no blueprints, no photographs. Just one line under final disposition: materials disposed of under authority of the Ministry of Supply, 1952. And yet, as recently as 2006, researchers examining a declassified RAF film reel noticed something odd. A short clip showing technicians testing a small turbine spinning without visible exhaust or flame. The caption reading simply, "Hybrid Propulsion, Trial 7, 1944. That clip vanished from the archive soon after its discovery. Historians continue to debate whether the engine truly ran without fuel or if the Germans misunderstood what they were seeing in 1945. But one fact remains. The recovered wreckage inspired years of quiet research into alternative propulsion, decades before the term became mainstream. For the German engineers who first examined it, the device was an artifact from another era, something beyond their technological reach. For the Allies, it was a reminder that even in war, innovation often outpaces understanding. In the words of Dr. Harold Beckett, who documented the Farnborough files before their destruction, "We were chasing a shadow of the future. The device was real, its purpose perhaps not of our time." Today, aerospace engineers continue to rediscover the same principles: plasma acceleration, magnetic propulsion, ionized airflow, all theories that were, in some form, hidden within that mysterious engine found in a wreck over 80 years ago. And perhaps that's the true legacy of the so-called Ghost engine. Not that it ran without fuel, but that it ran on imagination, on the boundless drive of engineers who dared to build something that shouldn't have existed. In 1945, German soldiers thought they had found a weapon. In truth, they had uncovered a promise, a glimpse of a future where flight itself would no longer be chained to the limits of fuel, combustion, or fire. A future where the sky and beyond would be powered not by what could be burned, but by what could be imagined.